Welcome back. In this lesson, we're looking at conditional statements, the way your programs make decisions. Conditionals are how code chooses one path over another. If something is true, do this. Otherwise, do that. Every non-trivial program needs to branch, to check user input, to handle different states, to react to the outside world. Without conditionals, your programs would be a single straight line of instructions that always did exactly the same thing. With them, your programs can respond intelligently to any situation. Rust gives you two main tools for branching: the if expression, familiar from other languages, but with a Rust twist, it returns a value. And match, Rust's pattern matching construct, more powerful than a switch statement, with compile time guarantees that every case is handled. By the end of this lesson, you'll know when to reach for each and how Rust's type system uses these constructs to eliminate whole categories of bugs before you ever run your code. Let's start with the familiar part. The if keyword lets you branch on a Boolean condition. You write if, followed by a condition, then a block of code in curly braces. If the condition evaluates to true, that block runs. You can optionally chain an else block to handle the opposite case, but Rust is picky in a way other languages aren't. The condition must be a bool, literally the value true or the value false. You cannot pass an integer and expect 0 to mean false or non-zero to mean true, the way you can in C or JavaScript or Python. If the compiler sees a non-Boolean in the condition position, it stops you with an error. This rule sounds annoying at first, but it eliminates an entire class of bugs where a type coercion silently flips a branch. Another thing Rust insists on: the braces around each block are always required. You cannot write a one-line if without braces. This rule sounds like extra typing, but it eliminates the classic dangling else bug that haunts C family code, where it's genuinely ambiguous which branch an else belongs to. Rust makes the structure explicit, and that means your code reads the way it executes. When you need to test multiple conditions, you can chain them together with else if. Rust evaluates each condition in the order you write them, top to bottom, and runs the first block whose condition is true. Once a branch matches, the rest are skipped entirely. The remaining conditions never even get evaluated. If none of them match, the final else block runs as a fallback. Every else if is itself optional, and so is the final else. Here's where a word of caution fits. Long chains of else if are a smell in Rust code. If you find yourself writing more than 2 or 3, consider reaching for match instead, which we'll meet in just a moment. The reason is partly aesthetic and partly about safety. Long if-else if chains read like a list of unrelated conditions, when usually what you really have is one value being compared to several possibilities. Match expresses that intent directly, and because match is exhaustive, the compiler will warn you if you forget a case. Else if chains offer no such guarantee. It's entirely up to you to remember every branch and to remember to add the catch-all else. Here's where Rust starts to feel different from languages like Java or Python. Remember from Lesson 2, if is an expression, not a statement. That means it evaluates to a value, and you can bind that value directly to a variable using let. Look at the example on screen. We have let number equals if condition, then 5 else 6. The whole if-else is one expression, and its value becomes whatever the chosen branch produces. There are 2 rules to keep in mind. First, both branches must produce the same type. The compiler checks this and will refuse your code if one branch returns a number and the other returns a string. This feels restrictive at first, but it's exactly what allows the compiler to reason about your program with confidence. You always know what type number has, because both branches agreed. Second, because the block's value is whatever expression comes last without a semicolon, you simply write the value on the final line. No return keyword, no assignment. This pattern, using if as an expression, leads to code that reads like mathematics. Concise, declarative, and surprisingly pleasant once you get used to it. You'll see this used constantly in idiomatic Rust, especially in one-line accessors, and small transformations. Match is Rust's pattern matching construct, and it's one of the most powerful tools in the language. You give it a value and then list a series of patterns, each paired with code to run. Rust checks each pattern in order and executes the first one that matches. At a glance, match looks a lot like a switch statement from C or Java. But match has a feature that fundamentally changes what you can do with it. It must be exhaustive. Every possible value of the matched type has to be handled somewhere. If you leave out a case, the compiler refuses to build your program. Consider the example here. We're matching on an integer. If the value is 1, 2, or 3, we print a message. Any other integer is caught by the underscore pattern, which acts as a catch-all. The underscore binds to anything. It's how you tell Rust you've considered every other case and want a default. Without that underscore, the compiler would reject this match because there are billions of integers we haven't explicitly listed. This exhaustiveness rule becomes truly powerful when combined with enums, which we'll cover in Lesson 7. Imagine you have an enum with 4 variants, and you match on it. If someone later adds a 5th variant, every match in your codebase that handled the original 4 becomes a compile error, pointing you to exactly the places you need to update. That turns the compiler into a refactoring assistant. Match patterns go far beyond simple equality. You can match a range of values using the ... equals syntax. 3 through 9, for instance, matches every number in that range inclusively. You can combine multiple alternatives with the pipe character. 1 pipe 2 means match if the value is 1 or 2. You can bind matched values to names, so that inside the arm you have a variable holding the matched value. And you can add a guard, an extra condition prefixed with the if keyword, that has to also be true for the arm to match. In the example you're seeing, we start with a 0 case, then a combined 1 or 2 pattern, then a range for single digits, then a guard catching negative numbers, and finally a binding pattern that catches everything else. Each arm tells a story about a particular shape of input, and the sum of them describes every possible path through the data. Later in the series, we'll see match unlock its full potential when paired with enums like option and result. For now, just internalize this. Match isn't a switch statement. It's a complete, compiler-verified way to describe every path your program can take. That's conditionals in Rust. In the next lesson, we'll look at loops, the tools Rust gives you for doing work over and over, with some clever twists you won't find in other languages. See you there.